Right, good afternoon, everyone, and welcome to our CAWASA Wednesday webinar. Though I have a new background this afternoon, no, I'm just using a different device because I'm multitasking in some other sessions. Today, we are pleased to have with us one who is well known to the water sector in the Caribbean region. He has been here for quite a long time. He is Dr. Adrianus Ton, aka Ton Vlugman, who holds a Bachelor's of Science in Civil Engineering and MSc in Environmental Health and Engineering at the Technical University of Delft. He's worked for PAHO, WHO throughout the Caribbean from 1987 to 2020. And the last years as Senior Advisor, Water Sanitation, Environmental Health for the Caribbean. He continues to be a member of PAHO's Emergency Rapid Assessment Response Team. He has responded to many emergencies since 1988. Most recently, Dominica Hurricane Maria and Irma 2017, the volcanic eruptions in St. Vincent 2021, the floods in Guyana 2021, Suriname 2022, Hurricane Beryl, St. Vincent and the Grenadines, and Jamaica in July 2024. His final project developed before retirement and funded by the EU focused on strengthening the resilience of health services to the impacts of climate change using the One Health approach and addresses explicitly environmental determinants of health in national adaptation planning. Other projects involving environmental determinants of health included Safe and Smart Hospital Assessor, integration of rainwater harvesting in water supply systems at healthcare facilities, WASH guidelines, that is water sanitation and hygiene guidelines for COVID-19, for groundwater quality monitoring, operational status of wastewater treatment plants in the Caribbean, solid waste management, planning, sick building syndrome investigations, impacts from small-scale gold mining on public health in Suriname and Guyana, health promoting schools, PAHO Centennial Project, community-based projects in collaboration with service clubs, for example, impregnated bed nets in partnership with Rotary International. Dr. Vlugman is married. He has 2 daughters and lives in Barbados. This evening, he is going to tell you all about his topic, and you could see that he is a well-tested and battled in the trenches with the water sector and the hygiene sector in the Caribbean through thick and thin. So he's going to enlighten us on a lot of what we can do, particularly during post-disaster events. Over to you, Dr. Vlugman.
Good afternoon, everybody. Can I share my video?
Yes, you can. Go ahead.
All right, so everybody can see my face.
That's right.
My old face. Good afternoon. I'm delighted to be part of the seminar hosted by CAWASA in collaboration with Operators Without Borders. And today I'm going to talk about disaster preparedness and special mitigation and standard operating procedures. I will now share my screen. This one, share. Okay. Everybody sees my first slide of the show?
All good.
Yeah, and I will be focusing on mitigation and SOPs. And this presentation is in collaboration with Operators Without Borders. For those who don't know about OWB, its purpose is to assist the water supply and wastewater utilities through training and mentoring, build capacity, among the water and wastewater operators in the Caribbean. The presentation will give some general considerations on what is emergency and what is emergency management. Risk management, risk assessment will be a part, will be discuss types of hazard we are exposed to, vulnerability assessment of water supply and wastewater systems, and then prevention, mitigation, SOPs. Now this presentation is, I've done this before, but it is a long presentation, but I will select a number of slides out of the total presentation is more than 100 slides, which I'm not going to do today. We don't have the time, but I will select, but in general, I follow this scheme. General considerations for emergency management. And it's very important to understand what an emergency is. A hurricane or an earthquake in itself is not an emergency or disaster. It is the impact from that event that requires a response that exceeds the capability of the response agency system to respond to that event, respond to the destruction or impact on the system. So that leads to a crisis situation. So it requires typically non-routine and emergency collective and collaborative action with the systems affected. And most likely it's not only one system, but several systems. I will discuss that later. So there are several phases: preparedness, prevention, emergency response, recovery, rehabilitation, and coordination and maintenance, and then the lessons learned for the next event. And preparedness, prevention is before the event. Emergency response is during the event, during the emergency, of course. Recovery and maintenance coordination is afterwards. And then evaluate the plans and use the lessons learned to make your plans better. It is very important that emergency management is embedded in the utilities organization and planning process from top to bottom. And the Caribbean has very much been exposed to several emergencies. So this is, the management is severely aware that they need good management and plans to address emergencies. Of course, intersectoral and intra and intersectoral cooperation is required because the power supply system, communication, transportation, and the health are all part of water supply and wastewater management. And it is very important that you're part of the emergency management, part of an integrated national disaster management planning. And I mentioned the climate change mitigation adaptation, and that's what, as Adrianus said, the last years I spent a lot of effort on developing plans to increase the resilience of the health sector. That also includes water utilities, using available climate change funds. There are billions of funds available to assist countries in reducing the impact of climate change, but you need proper plans, and you need these proper plans. The countries have adaptation plans also for the water sector. And to get this money, you need data. Data gives you dollars. All the plans must be quantitative. You must have evidence that you get you euros. Proof gives you pounds, and yen gives you yen. So remember this. There is money available in the international scheme, but you need good plans with good data to get access to that funds. Water supply systems are lifeline systems. That means they provide essential services on which the country and the society depends. Also during, of course, normal operations, but especially during an emergency. It is essential for the emergency response that your water supply systems are functioning, or to some extent functioning. The system is not by itself. It is, of course, dependent on interaction with many other components, electricity, roads, telecommunication. And of course, water supply systems are often dispersed over a large area, with your intakes in far away or in the mountains and long pipelines. And so you are exposed to many different types of hazards from all over the country. Lifeline include water supplies, sewer systems, wastewater, electricity, power supply, communication. Of lifeline systems, it's not only loss of revenue, but also loss of opportunity, loss of business opportunity, negative health impacts, which can be much larger than just the loss of assets and the cost for repairs. The lifeline systems, wait a minute, sorry. The water supply system must always provide safe drinking water, must protect public health from unhygienic conditions, contamination, spread of vectors, to secure socio-economic development and activities, and of course protect the investment of your assets, of the infrastructure. And it is of course very important to prioritize what is more important, but we will discuss it in a short while. Of course, I can have many slides on the impacts of hurricanes and disasters in the Caribbean, but I only show you a few here. Damage of Hurricane Maria, estimated more than $900 million. Losses to housing, 380 million. Severe damage to electrical systems and water supply infrastructure. I think it was about 41 out of the 43 water supply systems were out of operation. The reason I have a beard now is because I was in Dominica after Maria for 2 months, and I couldn't shave because the water quality was so bad. I got all kinds of infection on my chin, and I decided not to shave for 2 months. And when I came back, they asked me to play for Santa Claus for Christmas, and I liked it so much I kept my beard, although it will grow at Christmas time. Of course, water supply should be continuous, and service interruption or failure can maximize the negative impact of a disaster. And you should realize that the water supply is not only drinking water, because we drink 3 liters of water we use for consumption every day per person. But most of the water used in house connections, at least, is for washing and flushing. And these are essential services, especially during an emergency, that people can base and have hygienic situations. So even if the water supply cannot be guaranteed to be safe, stopping the water might not be the wisest thing to do, because people need washing and flushing water. But of course, it should be part of your response that if the water is not of good quality for drinking, that should be known, and alternative drinking water should be provided or available to the people. Okay, continuity is important. I mentioned here is another slide of some damage. This was in Costa Rica earthquake. And the cost for emergency response rehabilitation measures was about 9 million. But if mitigation and preventive measures would have been put in place, that would have been reduced to 5 million. So again, this investment in resilience will also make the system better and more resilient, and you will have less damage. And one of the new things as I said, I've been here for more than 40 years. Initially, the funding agencies were not building back better. They were just building or replacing what was existing with the same vulnerabilities. But in the meantime, the international community has realized that if we rebuild back to it should be with a higher resilience. River crossing should be better, higher, and less vulnerable to the massive flow that comes down the mountain after a massive rain or hurricane. We're going to talk about risk management. It's important to realize that risk is the concept of probability that something happens and the impact, the cost of it. It is the product of these two issues. And that's what you should realize. And that's what we're going to do in this exercise. We look at risk, which is the probability of something happening, and what is the disruption and the cost of the disruption. Of course, when water supply is not available, people will go to alternative sources, which are very poor for health, and people get sick. And the purpose of risk management is to reduce the vulnerability, thus increase the resilience. And I give here an example of making our river crossing earthquake proof. It is very important to realize that the extended water supply system and wastewater system have different hazards that can affect the system, affect the different components in different ways. So that means that you have to really look, what are my hazardous events, what are the different system components, and what is the impact of that component specifically. And I mentioned here a few: toxic spills, drought, earthquakes, landslides, bushfires now, earthquakes again, spills can affect your water treatment. Flood can affect different components. We have volcanic eruptions and can affect your system. Earthquakes and reservoirs and pipelines. Landslides again, hurricanes. All these different systems, components can be impacted on by the different hazardous events: fires, floods, sea level rise, surges. And I also mention here terrorism and cyber crimes. And it's very important that the system is as strong as its weakest link. If your main from your water source breaks, then your whole system has no water, if you have only one main. So these are also important considerations. And eventually you will do a risk analysis matrix, and for each different component and each different hazardous event, you will have something like this, that likelihood is very likely and the impact is critical or no. So you will focus in your response or in your preparedness and in your mitigation efforts and in your redesign and in your standard operating procedures. You will of course focus firstly on the critical, the medium, and then to the low. But that gives you thus a rational approach to what should you deal with. Events, I will go more detail. We are volcanic eruptions, earthquakes. I mentioned these, and the weather climatic hazards, hurricane, sea surges, droughts, and the man-made disasters. Here in another list, we list them, and we're all aware of them. And droughts are becoming more and more severe. And wildfires, cane fires, bushfires, they should be added, I believe. And we don't pay much attention to cyber terrorism, cybersecurity terrorism, vandalism, but they could play a role in the future. But it's something to keep in the back of our minds. What is the effect of climate change on the Caribbean water supply? This is a graph of the Caribbean. We have zone 1, 2, 3, 4 coming from northwest to the south, zone 5. Zone 5 is Southern Caribbean and the Guyanas. We can expect more intense rainfall in the zones 1 to 4, so that's the Northern Caribbean. Sudden changes in the dry and wet spell lengths. We have drier conditions in zone 5. That is the Southern Caribbean. Grenada is, for example, in zone 5, and they had a severe drought last year. More frequent, intense, and faster developing hurricanes. Remember Irma and Maria in 2017, they developed in Hurricane 5 within 1 or 2 days. Longer periods of drought and shorter but higher intensity rainfall that gives rise to more landslides. Of course, The more intense rainfall implies more stormwater runoff, flash floods, landslides, and our drain system should be able to absorb that or deal with that. And the Grenada Draft National Adaptation Plan is planning for projected decrease of up to 25% of the annual rainfall. And they were quite foresighted. In 2016, they already thought of how to deal with decrease in rainfall, and they are having some experience with this recently. For the Caribbean, there's a decrease in rainfall expected over the future, especially when you have a 2 degrees warming. We have now already 1.5 degree warming. Of course, the hurricanes, we have, of course, strong winds. We have also sea surges, which are most devastating, and heavy rainfall. Not all, but some hurricanes have a lot of rainfall. Picture from Marsh Harbor, Great Abaco. The the Haitian community in the mud was severely affected. This is a more panoramic view. It was the whole community was washed out. Thousands of people displaced, and I don't know how many people unaccounted for. Floods. You have to look at soil characteristics, the topography, the geography, of course, the rainfall, to develop measures to control floods or to reduce the impact of floods on your system and the drainage system that are required. Earthquake, the different issues that we have to be considered are the magnitude, intensity, probability, background data, historic data, seismic activity, and soil characteristics, depth to groundwater. These are all important aspects. Landslides, again, geology, topography, combination with earthquakes, rainfall, steepness, and so on. Volcanic eruptions, and there are different types of volcanic eruptions, pyroclastic, lava, a lot of ash, and that can also affect your system in different ways. Picture from the recent outbreak eruption in St. Vincent. Sea level rise can affect your groundwater sources, your freshwater availability, and there's of course important for those countries with groundwater. We go to the vulnerability assessments, and that also links very strongly to the standard operating procedures. A vulnerability analysis is a quantitative assessment on the impact of a specific hazard on the system and its components, and also how you manage those components. You have to look at specific hazards, and for each hazard you do an assessment on the physical assets and impact on service. You develop mitigation and emergency response measures. You develop a plan, emergency preparedness plan. You also look at the administrative aspects, the personnel aspects, and the company's response capacity. And this is all combined into a disaster mitigation and emergency response plan, of which SOPs are part. The vulnerability assessment, of course, are applied to existing systems, but also the outcome of the vulnerability analysis are important for the design of new systems, especially making sure that the systems are less vulnerable to the established risk scenarios. And of course, it is collaborative, interdisciplinary, as you can all guess, yeah. Not only the water utilities, but the meteorologists, geologists, hydrogeologists, volcanic experts, earthquake experts, engineers, consulting engineers, construction engineering, etc. Hurricanes, destruction of facilities by wind, of course, also by water, exposure to landslides and floods, and erosion, of course, of the pipeline, and damage to ground level and higher level storage tanks. I will discuss that later, and of contamination at the water sources and pipes. This is this construction of water reservoirs, destroyed during hurricane. Runoff, erosion, intakes are washed away by debris. These are two pictures from Dominica, and this is after tropical storm Erika, not even a hurricane, but heavy downpour, which washed away intake on the left, and here the damage on the bridge, and on this side were electrical pipes, and the other side were the water mains, but they were also damaged. Failure of electrical equipment is a serious issue after hurricanes and floods. Here we see the storeroom of batteries that are charged by solar powers, but there was no power after the event. That batteries had to be replaced, cleaned up. Floods include destruction of the river streams intakes, silting of distribution mains, loss of water supply of the river might have changed, the course of the river might have changed, rupture of pipes, we see that a lot, and contamination of fresh water resources, especially lakes and rivers, and damage to pumping equipment, flooding of pumping equipment, and damage to weirs and dams. Here we see a flooded pumping chamber, pumping cellar, destruction of mains, siltation of pipes. This is a sewer pipe, and of course sewer discharge can significantly affect the drinking water quality. The droughts have a main impact because you lose your resource, especially groundwater as well as river water. Groundwater has a little bit of delay time, but river water can go down very quickly. Degradation of water quality, you might need to ration, and abandonment of the system as a whole is a possibility. So you might need alternative sources. Earthquakes can render components completely useless, a complete write-off, have to be rebuilt. Earthquakes might also have aspects on the ground that are difficult to inspect, so you might have to dig them out to see where the problem is. Earthquakes can totally destroy catchments, dams, and rivers, intakes, pipe works, joints, collapse of building, loss of power supply, alteration of water quality, landslides, chemical hazards. That's a major issue, that storage of chemicals might be damaged and the chemicals run into your water source. Variation in groundwater level, etc. The location of springs. So these aspects you consider for landslides. I think I showed this slide already. Let me continue. So the water systems might be destroyed, pipes run away, especially in mountainous areas where you have public roads dig out along the mountains, and we're very familiar with that in the Caribbean. Contamination of water services in mountainous terrain. And here we see, for example, a storage tank on a hill, often built on a hill, and then the outflow pipe, and then after a heavy rainfall and a landslide, the outflow pipe is gone. So this is an extremely vulnerable component here. This is a temporary fix of water main that in Trafalgar in Dominica after tropical storm Erika. The river was completely washed away the pipe, so it was a temporary construction, and hopefully temporary is not permanent. Volcanic eruptions may damage lava flow, ashfall, And in St. Vincent, ashfall was major impact, and of course, the northern part of the country was a no-go zone, but it affected many of the intakes with ashfall, and also the treatment systems, change in water quality, contamination of rivers. It was also important to realize that although the water quality could not be guaranteed after the volcanic eruption, it was important to continue providing water to the community so people could wash and flush. And then drinking water was provided through the community. But since people drink less water than they use for flushing, the amount of water you have to bring, proper drinking water, is of course much lower than when you have to truck water for washing and flushing. Of course, volcanic eruptions can completely destroy areas, and left side is Montserrat. Plymouth is completely destroyed by the volcanic eruption, as was the northern part of St. Vincent. Again, we use this matrix with critical areas, with specific system components, and see where the impact is highest. So you can divide critical, high, medium, low, and that's where you put your attention in developing a mitigation for SOPs. In these presentations, I always highlight this, that failing to prepare is preparing to fail. If you're not preparing for a specific event, then you will fail when that event happens. That is basic. For hurricanes, mitigation measures, applied building code. Make sure you build according to hurricane categories that we can expect Hurricane 5, but you have to have at least building that can withstand Hurricane 3. We have to build better bridges and strengthen river crossings. There's I think a very major deficiency in the Caribbean. Provide adequate drainage of stormwater. And very often I see pictures of flood zones, and you can see that the new road that was built is actually obstructing the natural flow and discharge of rainwater in that area. And the culverts underneath are not big enough or get clogged. But adequate drainage needs a lot of attention and building coding in the Caribbean. One of my favorite stories is as part of the SOPs is when you have a storage tank, fill them up before the hurricane hits. And then just an hour or 2 hours, we know when a hurricane is coming to arrive these days. So just shortly before that, you close off the main valve so the tanks remain full. And when a tank is full on a hill, it's also very strong. And then after the hurricane, and after the all clear is given, you check your system, but then you have at least a lot of water stored. But I've seen it too often that during the storm, the main from that storage tank is broken, and when the outlet valve is not closed, the tank will drain during the storm, and then it might also be damaged by not only do you lose the water, but the tank might also be damaged by the storm. Also important is water catchment protection zones, especially where chemical storage is near sensitive areas. You might wish to remove them. And these things are also part of the vulnerability analysis. Of course, use the existing mapping on flood zones and recurrence area, and you should not build essential services in flood zones. Very simple. Of course, storage of especially chemicals should be dry and flood free on higher elevation and with proper drainage. Drought, that is of course, drought reduces the volume of available water, but how do you mitigate for that? Is make sure you have alternative sources or try to develop them. That is also what Grenada is doing, look for groundwater sources or desalination, which is more expensive. Assessment of the quality of those alternative sources And look at reduction and conservation measures, reduce the unaccounted for water, which also is better operation, right? Rationing possibility. I have a lot of slides on seismic hazards, and I don't want to read them too, because we also have a question and discussion time. So we'll go quickly through these. And actually, these slides will be in the final, will be available to you, so you can also read it out. So ground shaking, of course, make sure your design has seismic consideration in. Liquefaction, you might do some soil improvements. And weight. Liquefiable soils, materials, retaining walls, etc. Can all read that up later. Landslide common 4 groups. Fall and toppling, slide along a rupture layer, lateral spread and flows. Proper drainage, as I said, proper drainage is really, really important. And really we should put more attention to that. And of course, tree planting and root development will stabilize soils. Settlement, densification and cracking of soils, soil density improvements, fault rupture, mitigation is don't build on fault lines. And if stabilization. Redundancy is very important. If you have two sources, connect them so you have and double intake, so you have redundancy. If one damage, you can use the others. That's a good strategy. Here is an improvement of a column for water main to resist earthquakes. So that is an improvement there. Storage facilities should be outside of a flood zone, should have proper drainage in case, and should not be, like this is an example in Haiti, where the whole storage facility damaged, but it was preventable. And this is, what is this? During the design phase, look at make sure that your system is not vulnerable to, in this case, is mountainous arid terrain. This slide I kept in because very often I see that temporarily fixing end up to be permanent, and it works, so nobody does anything until it is another disaster or a minor event then damages the system. So if you do a temporary fix, make sure that it's quickly changed into a permanent solution. I've seen it too many times. And of course, build back better, very important, that the future similar event will not damage the pipe. Volcanic eruption mitigation includes hazard mapping. Of course, you know where the volcanoes are. They're standing out in the landscape. But you have to cover your treatment plant or make facility to cover them in case of an ash fall. And of course, good building codes and fire prevention strategies. We have some examples here from covering your filters. And alternative water sources might be important. Here are some pictures from St. Vincent where the sand filters had to be cleaned out. The ash had to be cleaned out from the sand filters. Mitigation, here is a leak in a crossing, and it's very important that standard operating and maintenance programs should do corrective action to reduce the vulnerabilities. And this is a picture of this was not done, and the system broke afterwards. And actually, mitigation measures can be very simple. Fix things that are broken before the event happens. And mitigation does not only improve the capacity of the emergency response, but it also protects and improves the routine day-to-day operations and make the system more resilient and reliable. And it also enforces and strengthens operational maintenance, especially corrective and preventative maintenance, and the implementation of standard operating procedures. And these go hand in hand. And as preventative maintenance is a big issue, and we should pay more attention to that aspect, because that reduces the vulnerability significantly. And when it comes to SOPs, we don't need to reinvent the wheel. Although today, I read an article that somebody in Australia patented the wheel, which was part of a joke, but he got it patented because of some weak patent rules, legislation in Australia, but you might wish to read that article. This is a story that that reminds me of that incident in Montserrat, where a water tank was blown off the hill because the outlet was not closed off. The tank was full before the hurricane, but the outlet valve was open. A tree downstream ruptured the main, and the tank emptied. And I did a similar training in 1991. I was then at SEHI, and I invited all the men of the operators, chief operators of the utilities, and we discussed, listen, before the hurricane, fill the tank, and just before the hurricane reach, close the valve so you have water stored. And in 2015-16, I was having a CWA meeting, and I spoke to Mr. Husband of Grenada, manager of Grenada, and he said, you know, I learned so much from Hurricane Ivan, 2014, that was 23 years after 1991. Yeah, what we should have done, we should have filled the reservoir and then closed the valve before the hurricane come, because we lost all the water. You see, and so it is important that the standing operating procedures that were actually already developed 25 years earlier were not institutionalized within the utility. And the person I trained apparently retired, and the knowledge went with him. And the standard operating procedure should be institutionalized. It should be part of the business continuity plan to define the procedures for preparedness and response to the specific hazards. My experience is also that in the Caribbean, many utilities focus on hurricanes and floods related to hurricanes and landslides, but we need all the other incidents. And the SOPs must include realistic risks from other hazards like droughts, floods, sea surges, tsunamis, landslides, earthquake tremors, volcanic eruptions. And droughts is now getting high on the agenda because of recent experience, but we need to expand our SOPs to have these realistic scenarios addressed. The SOPs are based on the vulnerability assessment and include time-based instructions for the before, during, and after the impact for staff to implement measures for the identified vulnerable system components. And the SOPs include function-specific interventions, which will be an integral part of the job description for that specific function and post. So everybody who gets a job must be the job description should have a page attached to it, stapled to it, that comes out of the business continuity plan, and this is your task at these times when these kind of events are happening or going to happen, and after they happen. So the SOPs are incorporated and institutionalized in the utility. They require training and regular updating, and apply the lessons learned from previous events. SOPs are always, and business continuity plans are always work in progress. They're never perfect, but you need them and you can improve on them with the lessons learned from an event. This is, in short, the presentation. I see there were 117 slides. I didn't do all of them, but I will make all the slides available to you all. And this is time for questions and discussion. I can now stop sharing the screen. Everybody still there?
Yes, we are, Ton, and thank you so much for this very comprehensive, albeit you had to compact it within a short window.
Yeah.
But I think it was well done. I think there are quite a few areas that you have to that you mentioned, for example, things that are done temporary. They're supposed to be temporary structures in the quick response, but they eventually become permanent.
Yes.
And the issues of building back better. And of course, that SOPs have to be institutionalized.
Yeah.
And it's supposed to be part of the business continuity plan. They need to be updated because many utilities will have had even business continuity plans and certain SOPs, but it's perhaps done a decade ago or maybe less, but it has to be something that has to be dynamic, as well as our focus on natural hazards, particularly those of hurricanes, and the need to update the focus to be on expand the focus into other hazards, particularly droughts, and of course SOPs that depend on the vulnerability assessments. And I know too that the CDB had done some time ago, maybe about 7 years ago, a vulnerability assessment or some manual the CDB had. So some of these things, and including the 5 Cs, had done on a list of SOPs for the utilities. So these are some of the documentation that is around, but I think in addition to the operators, these are some things that would have to be taken up with the supervisors and senior management. But over to you, Valerie, you have a question.
Well, just a comment on the SOPs, as I think we have told people before, Operators Without Borders has developed 225 SOPs for everything from water distribution, treatment, wastewater collection, treatment, safety issues, lab issues. And we just give those away, and they're available through me, or you can ask CAWASA. You can pick which ones you want. You can pick all of them if you want. There's no charge whatsoever. And to help you customize them, we would, assign a volunteer to you to help you customize them. So because I find that so many utilities in the Caribbean just do not have many SOPs at all. It's in Canada, it is mandated. It is illegal not to have SOPs. You can be fined $100,000 if you don't have SOPs on certain things. So all you got to do is ask us.
Yeah.
Thanks.
Yeah, if I may add, because SOPs is not rocket science, and the basics of it are available, but you have to customize them, and you have to link them to somebody who does something at a certain time within that organization. That is not something that an external agency can do. You have to do it with the utility. That is very important to realize. You cannot just give it to a consultant and get me a booklet. No, it is a approach between a consultant if necessary, but also within your own organization. When you have a generic SOP, then you customize it to your specific situation.
Yes.
Your location, the GPS location of this pipe or this pump station, and the person within your organization who does certain things at certain times, or the function that does that, because the function, the person might change with the function. Anyway, but that's very important.
Yeah.
Any questions from the participants?
I don't see any in the chat or yeah, I see Kevin Carter has his hand up. Go ahead, Kevin.
Hi, greetings from South Florida. Good to see you, Tom.
Hello,
Val,
Kevin.
Ignatius, and everybody else. Mine's more of an add-on, I guess, and to your build upon your point that SOPs are livable documents and from things you learn. As some of you know, I'm the steering committee chair for the Florida Water and Wastewater Agency Response Network, which in Florida, that's
Yeah.
Or you just froze out there.
yeah. All right. Can you hear me now?
You're
Yeah.
back.
Yeah.
Yeah, there you go. Power. You live with power or die without power, right? So anyway, what I was getting to say is we're utilities that help utilities after a storm. We send in mutual aid. And I know Quick, the Caribbean Water Utility Insurance Collective, is
Yeah.
looking to that. So what I'm going to talk about, and you can build upon, is we're really asking our utilities to think about and put in SOPs how you receive mutual aid, how you would show people your systems after a storm, especially knowing that you're going to be in shock. Your original plans may have been blown away. And then on the other side, we're asking utilities to think how they are going to respond and put that in SOPs as far as gathering the right equipment, getting the right information. And so I just wanted to add that to the conversation because I know Quick is up and growing, and I think it's a great program, and I think it's going to have a lot of benefits.
Yeah, I forgot to mention Quick. Yeah, I was thinking of putting a slide on Quick. I will add it to the presentation and make it available to the participants so they know about it.
Any questions? I'm not seeing any others. Yes, indeed, in the quick response program, the Caribbean Water Utilities Insurance Composite.
Yes, exactly.
Yeah, that is segregated portfolio. There will be the first component will be the sort of mutual aid response mechanism that will be established. And the other component, the second component, is the actual insurance for the utilities assets. But this first component is where we as operators, there will be a component to have the various, of course, the SOPs will have to be developed and the whole manuals, as well as there will be each training of the teams within each utility so that should there be an event, they would be able to respond promptly and they will have the various equipment and toolkit, as we call it, available. So this is a work in progress.
Because what I wanted to say in my presentation earlier is that Quick is an insurance scheme, and the insurers, what all they do is risk assessments, and that's basically what it is. And they are, with the Quick program, they are actually want to reduce the risks of loss of money and reduce the vulnerability of the system they are insuring. And that's why you have to do vulnerability analysis, and that's why you have to do mitigation, and that's why you have to do standard operating procedure. But it is financially driven through the insurance companies. And that is an important, thank you very much, Kevin, to remind me of that. I will add 1 or 2 slides on this.
We have a question in the chat, Ton. It's from Karen Martinez of GWPC. He asked, are SOPs designed to deal with multiple hazards occurring at the same time? Can there be several combinations of possibilities that are hard to predict, for example, earthquake and hurricanes?
Well, as of your vulnerability analysis looks at the different hazards. yeah, there is, if you have a SOP and a mitigation and emergency plans for earthquakes, and you have also one for hurricanes, and it happens together, yeah, then you have to put them both in place. Although I think the probability of that happening is extremely small, but it is there. It is there. Also, a volcanic eruption during a hurricane is theoretically possible, but that means you have to have mitigation plans and business continuity plans for these different scenarios and possible confluence of the scenarios.
But you certainly can use them in multiple hazards.
Yeah, you can. Yeah, but you have to have a mitigation plan or the
Yeah.
response plan for the individual events. Of course, if you have a serious earthquake during a hurricane or just after the hurricane, you have a serious problem, of course.
Earthquake is a little bit more difficult because it isn't predicted.
Yeah, exactly.
The hurricanes, we
That's
know it's coming, and you can do a lot of mitigation
Yeah.
to reduce your risk. You know, putting up your shutters, you know, taking down the computer systems, etc. The earthquake that just hit.
Yeah.
We've had 2 earthquakes in the last week in Vancouver that shook us a bit, and hopefully it's not portending a big one.
Yeah. So you have to add the different scenarios together. Yeah.
Any other questions or comments?
Or if I understand the question properly, I don't think you have to write SOP for hurricane and earthquake. I think you must have SOPs for earthquakes, and you must have SOPs for hurricanes. But you don't write one for hurricane and earthquake. You just use the different and merge them.
Right. I don't see any other questions or comments. Save if you have. I don't have any others myself. I'd just like to, at this time, thank you, Ton, for an excellent presentation and for your time to share your vast experiences with us. And we know you're always at hand. Oh, I think Kevin is on again, or is that an old hand?
Just
Yes,
real quick.
Yeah.
Tom's right. You have the SOPs individually, but I want to give a shout out for OWB that we put out incident command system training. And that's using that process allows you to handle multiple events at the same time.
Right.
Okay, part of the training, yes. Okay.
Thanks,
Yeah, because that is the major thing. When you have SOPs, you have to practice and train them, and in among others, the incident command center training, because you have to practice, because else you don't know what you're doing. It's very simple. It's my strongest experience. You have to practice these emergency plans, like you have to practice driving a car. You have to practice how to implement these plans. Yeah.
Yeah, in fact, well, just about 2 weeks ago, we met with Sedema, and we are now trying to set up this WashLAC, focal point within the Sedema in collaboration with UNICEF and a lot of the other partners. I think we have some draft TORs, which gives us a framework of how we're going to operate within the Sedema framework. And so that's a work in progress as well. And we hope that we'll be able to help the utilities, because prior to that, they didn't really have, they depended largely a lot on you alone, Ton, and from PAHO perspective. So we're trying to expand that. Whilst we had some ad hoc arrangements, we're trying to formalize these arrangements.
Extremely important what you just said.
Yeah. So
it was just too bad. As Ton knows, Ton and I were working on a business continuity emergency response plan SOPs for St. Lucia, and we'd put a lot of work into that, and Kevin was part of the team. We put a lot of work into it, and then at the last
Don't
minute,
say it, don't say it,
yeah.
don't say it on this platform. It's a
Well,
period of disruption and
Yeah.
uncertainty, and we'll leave it there.
yeah, well, it was a real shame
We will
overnight.
do. It will happen in the
Yeah,
future.
but we are resilient people in the region, and
exactly.
we have been there, and we will survive.
Yeah. We
Yeah.
will
I don't know about Canada right now, Ignatius. We're in the crosshairs.
No, I'm still alive. Okay, so thank you very much, everyone, for joining us.
Thank you.
And we look forward to seeing you next week. I will send out the notices by Friday latest to keep you posted. And meanwhile, those of you who are just a little reminder and a plug for us at CAWASA that we are well into preparing for our 8th Water Operators Conference to be hosted in St. Vincent, together with the Central Water and Sewage Authority of St. Vincent and the Grenadines. And that will be from June 25th to the 27th at the Beachcomber Hotel in St. Vincent. So you can always drop us a line and we can always give you more information on that. Up to now, we are still upgrading. We are revamping our website. So we've had a little challenge there, but we should be back and running pretty soon. But you know how to reach us. Okay. Thank you very much. Have a good evening.
See you next
Good
week.
evening. Bye-bye, everybody.
Bye.